Okay, today is 20th of August 2026. Time now is Thursday, it's Thursday 20th of August 2026. Time now is 12:07 a.m. Yeah. So I've got this image here. I'm gonna share my work. I did. Yeah. This is a neuron. I'm gonna read the title out. Sigmoid spatial. I'm writing it down. This is about brain computing interfaces, spatial sigmoid activation function, I put functor there, via uh, cross via a cross product. That should be seen hand. This is, I'm going to trim the title. Let me just put it again because it's not making sense to me. Spatial sigmoid aggregation function via right hand rule. So you get the right hand rule, which is like this, but it has nothing to do. Wait, it has nothing to do with the same, does it? Or does it not? Let me start with the overdue, but I believe it's related. So here it's not the right hand rule is not related right now. But we're gonna look at this spatial sigmoid activation function. I wrote here functor on my book. So this is the image here. So basically, you have here a set of neurons to activate, but there's some kind of input. You need to get them to activate. When they activate, there's some domain. They map some domain, one domain to a set of portable outputs. So basically, they have one neuron can have many outputs based on how it's connected. So, for example, this one. Wait, oh, I didn't do it right. Yeah. So basically, you see all these neurons here. Uh, so look at system neurons. Basically, this is a neuron. A neuron. And this is first an input. There's an input to an output, but this input is a domain. This is the range, but the range is a set of ranges that can be activated. So this neuron can activate two other neurons on the left, on my left, because this is like a coordination between the brain, computer universe, and actual motor neuron. The motor neuron. So it's called the motor neuron. So it should control something. So if you have a thought process, it uses to control some kind of output, like someone that or paralyzed or like in a wheelchair, can still control robot arm by using it to by just a thought power of thought. So these are the kind of activation function. This is where a sigmoid function become. A sigmoid function is a function that has an input between basically for set of range, obviously for set of range. Let me remember. It has wait, is it final set of ranges? I have to remember. So basically, sigma function is between 0 and 1, map between 0 and 1, and that 0 has a array of ranges. So you can have like a minus 10 to 10 or minus 6 to so you can have minus 6 to 6. Let's see, minus 10 to plus 10 and 0 to 1. 0 to 1. This is example of single function. So this is basically so for all the domain here, this is what I'm saying. So this is the same concept here, but some kind of model of it. So this is like a spatial because it works on XYZ like the longitude, latitude, and longitude because some motor because of coordination. So like if I basically if I'm taking my if I am uh I want to use complex number to model it, but I don't want to use it complex numbers yet because I haven't got the concept yet down. But you're gonna use like imaginary units and real units to indicate activation, to better indicate activation. But yeah, it's of course signals. So example, you have here 0 to 1, 0 to 1, and 0 to 1 represents activation function from some threshold, like minus 10 to 10, minus 10 to 10. That's basically the map of because this activation, the threshold for activation is 0 1. Any value in between this value will activate a range from minus 10 to 10. Yeah, from 0 to 1. Uh, Yeah, so it's basically so if you pick 0.5, you're talking about the 5, you're talking about 0. 0. If you're talking about 0.5, it's talking about 0 because wait, because it has been activated here. The threshold has not been reached, so it has not wait. Am I right? So you're talking about 0, you're talking about not being activated. You're talking about 1 being activated. So you're talking about 0 to 0.5, you're talking about somewhere in between, like a curve, because it's a curve, isn't it? So it's gonna be a curvature, like it's gonna be ellipsoid, elliptic, elliptic curve. It's gonna be elliptic curve. So on this graph, it's an elliptic curve. But this is not right. I'm gonna show. This is minus 10 to 10. So that's just the line. So this is a more accurate definition because this line goes from minus 10 all the way to 10, minus 10 all the way to 10. Yeah. And this is minus 10 all the way to 10. Yeah. So some threshold here will get activated, based on 0 to 1. Based on the inputs of 0 to 1. But the inputs are 0 and to 1, but the domains ranges are the 10 to uh, plus 10 to minus 10 to plus 10. Yeah, this is the ranges. So the same concept applies here. So in 3D space, we have longitude, latitude, and altitude. So we have to have a tripartite. No, I don't like to say tripartite. I like to say let's have three neurons. So basically, the idea is you have uh, three spatial lines over a graph. It's a graph basically. So you draw three elliptic curves. So basically, three elliptic curves that are using the cross product rule. Basically, the right hand rule. So the right hand rule basically uh, uh, you get x y z. You get x y z. So you get a right hand rule. So this is the right hand rule here. So basically you get the hopefully I'm getting this right. This is the x. So if you start, this is 0 here. The x will go only map to the x plane. The y will start at the y plane, x plane, and map to the y plane. This will go here. This will go here, and this will go. And this z use the x and y. So we'll start here. We'll start at the bottom here, where there's like a between space x and y, and go all the way to the top z here. So that's the idea. So here I'll show you how to do it. So you're gonna get this line is not straight. So I hope I'm doing this right because this is gonna fail if I don't do it right. Yeah. So you're gonna have yeah. So you're gonna have the cross product of this is x y z. So you're gonna have starting here. You're gonna go to the side, or this is the right hand rule. So basically, if it's right hand rule, I'm gonna start. You're gonna see people left hand rule. Basically, the left hand rule is more natural because it's starting from. So basically, this is right hand rule. I'm pointing it. So this is like the right hand rule. So using my right hand to calculate the vector cross product. Yeah, so I'm using the right hand to cross product. So yeah. So I'm looking at it downwards. This is the space in the plane here. This x y, x and y space. This is z spaces. Whole space is z here. So this is the right hand rule, and you're gonna have that. You're gonna have the. So this is 0, 0. This is the 0, 0, 0. Gonna have 0 go here. So this is a going out this way. Well, that doesn't feel natural, so I'm gonna use the left hand rule instead. So I'm gonna use because it's more natural for me to use left hand rule because my sake. So this is why I'm using it. So it's gonna use left hand. So I'm gonna start here and go out right, go out right, go out right, to opposite right. So it's gonna be from the center, to go out right will be yep. This is the first line I drew. So this is what I did. Yeah, so this is the first thing I did. This is the activation function, general activation from 0 to 1. 0 to 1. So basically, 0 to 1. Uh, yeah, I haven't drawn the actual z axis. See, this is the just from 0 to 1, 0 to 1. Yeah, I'm gonna do this right. Yeah, I'm gonna do this right. Yeah. 0 to 1. And you're gonna go 0 to 1 to 1. Yeah, this is a mapping of 0 to 1. So basically, we're gonna start here. So 0 to 1 is here. Yeah, so we're gonna go over, and then from here we're gonna go there. It's gonna start at the midpoint from basically you're gonna have at the maximum. Basically, this is a zero. Basically, this is a 0, 0, 0, 1, 1, 0. It's gonna start at the. Think of it as a net geometry, like a net. So if you think of a key, the net of a square, you have 0, 0 or 1, 0, which represents y, 1y, 0x, and yeah. So this is a activation. So I'm gonna try to do that way actually. 0, 0, 0, 1, 0, 0, 1, 0, 1, 0. 0, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 0. So basically, yeah, so the activation function is that. So the 0, 0, 0, so 0, 0, 0. So we're gonna have this kind of geometry element. So I'm gonna keep going with the mathematics there, with the model. But so you're gonna have 0, 0, 0, 0, 1, 0, 1, 1, 0, and 1, 1, 1, 0, 0. So that's like this. So if you start at this interval, you're gonna have another interval that's orthogonal. So basically, this one's here, 0, 0, 1. zero 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 0101 000. Well, I'm gonna go to Nigeria, but God, you say like you want to go to Nigeria. I do want to go to Nigeria, guys. I do want to go. I want to go home, but I want to keep my house, so I have to go and keep my house. So you're gonna have yeah, I want to go here. 10100. This is literally one one one. So if you're gonna have here, it goes here. And from here, this is XY. It goes up, up. Which is you're gonna cross the dimensional Y. Is it? I said here. This is my Hawaiian rule. This is not here. 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 Or start. Or this is the zero start here. So you're gonna start here. And you're gonna cross. This is gonna start at 111 and cross through the center to Y. No, this is the Y here. So if we cross here. So if we start here, because this is maps. This is 000 to 110. And that's basically the Sigmod function mapping all the range of inputs from all natural numbers or all real numbers or all you're gonna have that numbers. You're gonna have that there. And you're gonna have this function go from this. Is this to the side? You have to go from here to the top one. No, this is going away. So I'm gonna start from here to here. So you're gonna map from all the ranges from 101, yeah, 010 to 111. No, 110. No, wait. So you're gonna map all the way. So you're gonna stop. You're gonna have a mapping of 010 to 111. I'm trying to for 111. But this is center here. Yeah, so you're gonna map to 111. Where is 111? 111 is here. So you're gonna map from 110 to 111. You're gonna have a mapping from uh this should be two. So this represents activation of neurons. The problem I'm having right now is usually you're gonna have XYZ, so you're gonna have coordinate system. I don't like saying XYZ coordinate system. I like using the term planes, geometric plane. Is it? Basically a plane. So you're gonna have a mapping to correspond to the plane. But these are activation functions, so they have to range. They have to have a. They have to use. They have to map. Yeah, I don't think this is right. I think I messed up. Oh, this is 110. Oh, oh yeah, this is 100 to 110. Yep, it's gonna start at 100 to 110. I'm gonna have something just across this line. So basically, you're gonna have two 110. You're gonna have 110. You're gonna have 0, 1, 1, 1. So this is start at this is x starts at 1, 1. X starts at 0, 0, 0 to 1, 1, 0, and y starts at 0, 0, 0 to 1, 1, 1. And y starts at 1, 1, 0. Y starts at 1, 0, 0 to 1, 1, 0. Yeah. Yeah. This is not making sense. This is making great sense to me. So I haven't really wait, 1, 0, 0. Wait, zero was one. It sounds like I'm talking about ones and zeros. I'm like I don't know. Well, I'm talking about binary. No, I'm talking about binary. No, I'm talking about binary. I'm talking about like what it means to activate a function. So the basically basically you can calculate it using the left hand, like so x y, it goes here, here, and we'll go from here. We'll go here. So if you're gonna go here, and you're gonna cut through the middle. Because it's gonna start at y is gonna start at 1, 1, 0 to 1, 1, 1. That's the idea. So that's the idea. So basically, the as you can see, the mapping from 0, 0, 0 to 1, 1, 1, 1, 0, 1, 0, 0 to 1, 0, 1, 0, 0 to 1, 1, 0, which is what I wrote down here. Uh, should be a 1, 1, 0 to 0, 1, 1, 0, 1, 0. This should be 0, 1, 0. Well, what is x and y? This is 0, 1, 0 here. This is 1, 1, 0 here. And this would be 1, 1, 0. This is 0, 1, 1, 0, 0, 0, 1, 1, 1, 0. Well, shift to here and 1, 1, 1, 1, 0, 0, 1, 1 to 1. Yeah, so that's the idea. So I'm gonna read again 0, 0, 0 to 1, 1, 0, 1, 0, 0 to 1, 1, 0. No, 0, 0, 0 to 0, 1, 0, which is y. Y0. Gonna get 1, 0, 0 to 1, 1, 0, and you're gonna get 1, 0, 1. I mean 0, 1. I mean 1, 1, 1, 0, 1. Is it 1, 1? Obviously, the end is 1, 1, 0, which is x and y effectively, and you're gonna get 1 started 1, 0, 1, 0, 1, 1, 1, 0. You get 1, 1, 0 to 1, 1, 0 to 1, 1, 1, and that's the end of it. So yeah, so now 0, 1, 1, 0 to 1, 1, 1. Yeah, which can also close. Yeah, that's correct. So that is correct. And yeah, so basically that's not activated here. Basically, that's a set of range from 0 to 1. So The range, this is just the mapping, the first mapping. So the mapping can be from minus real. Okay. Let's say minus r to r. Uh, or minus infinity r. Okay, minus real to real, minus natural number to natural number. Any natural number on the range side, but yeah, but wait, the domain is input itself. So the domains are literally the natural numbers. So that's what I'm saying. So the goal is to have the activation function which you map the the space to the real numbers. Like the obviously it will map all the coordinate system to the real number. So that would be, for example, if you're gonna have like a minus 10, which is a real number, which is the real number or counting number, and you can have minus 10, 0 or 1, minus Rn, R small little n. So where n was the set of natural numbers, where n is the set of natural numbers. Uh, 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 so so I'm going to use a big N. So I'm going to use Rn or the Rn. So real numbers are natural numbers. Yeah, yeah. So you can have zero decimal places or natural numbers or counting numbers. National Metal Casino at the end. So you're gonna have I don't wanna I think I'm making a mistake here. But so you're gonna have any activation trigger a neuron. So the goal is to have some correspondence. Objectively, you're gonna have some correspondence between this model and the inputs, like the relationship of the inputs, the domain and range of the inputs. For example, I'm gonna use like this is a tuple. I do down this is a range, this is a vector, this is set. This is an array. This is a set. So you're gonna have unbound set because you have if you have the basically this is what I did, guys. It's not even clear, but I'm trying to do it. Well, so for any kind of partial input, any kind of real world input, there is a propagation of the data. There's a way you can propagate in the there's you can activate it. So you can say, okay, this is now time to process this input, this input. So the input is the domain between basically this is just a graph. This is just a graph. Here this is a graph of it, and this is the coordination. This actually determines so the threshold basically this one I'm saying. So this is what we started with. So this activation. So this activation here. So this is a mapping of the activation. So basically this node, this input A, this input here, this neuron here can have a connection to this one and this one only once, like a set of hundred. We can connect to two outputs, two neurons. So this unique connection. It's not like an output. It's like the domain is mapped. It's mapped to. So this is like a two different neurons. There are four neurons here, three neurons on the right and two on the left. So there's one neuron that shares only shares three. So this one neuron has three output neurons. So you can activate three separate independent neurons. Yeah, independently of each other. So depending on the inputs, based on real number and natural number. So I'm trying to formalize that now. So one formalization could be uh, having the real numbers mapped to having the real numbers you're gonna have here and here. So you're gonna have this here mapped to this one there, this one there, mapped to this one there, two more there. But it's three inputs you're gonna have. I wanna go to Nigeria, so I wanna go to Nigeria right now. But sorry guys. Computing. So this is the input here. So this is the input. So see how it goes up. See how it goes up. So this is a not. This is not in relationship. I said it was the basically. This is kind of like that, but it's not. It really the same was being activated. So depending on threshold, what gets activated is the domain. So the input, the output, which is the output. So like this one has one relationship, only one relationship. So you can only activate this one. So if you basically if you have a movement, if you have a if you have a motor, your motor basically your motion is connected to your yeah so your space, but the neuron activate. So when it's activated, you can activate more, and there's a final mapping to the it has to be a map what am I correctly, and that works like this. So if you have this one, the first neuron come is mapped to is connected to the third one. The second one is connected to the first one. The second one is connected to the first one and the last one, and the fourth one. The third one on the left is connected to and the last one and the third one. The third and the last one. The third one is connected to the one, the second one. So basically, this is mapping here of neurons. So basically, the first neuron is mapped to the third neuron. The second neuron is mapped to the first, third, and fourth neuron. Okay, the first one is connected to the third. One, two, three. The second one is connected to the first one, the third one, and the fourth one. And the third one is connected to the second one. The second one is connected to third one is connected to the second one. And that's what I'm saying. So basically, it's neural activity. So it's literally just connected it's connected by, but it's not activated. It's like mapped to like connected, it's mapped. So it's connected, it's mapped, but it's not activated. So it's only sigma function, the partial sigma function kind of basically the goal is to activate tune uselessly if you're doing neural networks, you're mapping out, I've never done neural networks in my life, but this is my because I don't wanna go to the book. I don't wanna go to the book and get stuck in something I don't know because basically I'm only doing this because so this is expecting to work in the kind of formal sense of the word. But I haven't read the book. I haven't read the book on neural networks. I only hypothesize what it means to be what it means to be how neural networks work. So this hypothesis, this is like how it should behave in terms of how I approximate how I've come up with the idea of neural network. This basically the attribution functions used to like show a sigmoid function that activates a neuron, basically a fire of electrical signal in the brain uh, that coordinates a motor action via a brain computer interface. So we're gonna define problems in this domain now. This is the recording. Okay. Okay, my video stopped.